Hello, everyone. Yesterday, or the lesson before this, we started out with a couple different types of equations. We did those first degree, some absolute value equations, and quadratics, those second degree ones. So today we're going to talk about a couple different more. We're going to start with some radicals. Now, radicals are, if you want, there's a little bit of a connection with that square root method we did from the other lesson. What we're going to do for this first one is, how do you get rid of a square root? Well, you square it. So what I'm going to do here is, I've got my radical x is equal to 4. What I'll do is I'll square the left side, but what you guys learned very early on in math is if you do something to the left side, you must do it to the right side. So let's just double check. Square rooting a square root. Squaring a square root gets rid of it. 4 squared is 16. Now, it is super important. We do want to pay attention to this right here. Be sure to give a mental check to check for extraneous solutions. Sometimes things that we solve for are not always going to check out. So we want to make sure we're looking for that. If I plug in, again, mental check. It doesn't have to be written down, but I can't really show you a mental check other than me writing it down. So when we do this check, again, mental is okay. I cannot stress that enough. Square root of 16 is 4. 4 equals 4. That works out. This is a good answer. Okay? So you guys can do that in your heads. Totally okay. Now, let's apply what we just did. We squared a square root to get rid of it. So how am I going to get rid of a cube root for question B? Well, it's exactly what you would think. If I square a square root, I want to cube a cube root. But like we just talked about, if you do something to the left, you have to do something to the right. So cubing a cube root leaves us with x plus 1. 2 to the third is not going to be 6. That is 2 times 3. That is a bad mistake to make in this class. 2 times 2 is 4, times 2 is 8. So we're left with 8. Subtract 1 on both, I get 7. Again, mental check. So cube root of 7 plus 1 is 2. Cube root of 8 is 2. 2 equals 2. This is a good answer. Okay. Well, when is something going to be a bad answer? Usually not something like that. Usually something like those we'll be okay with, especially if under the radical is a first degree term, like on the letter A, I just had x. In letter B, I just had x plus 1. Very low chance of getting anything wrong there. Something like C, where it's definitely a little bit more complicated, or if there's other things under that radical, that's usually when the check is definitely more needed, more necessary. But something like C, not too many of us have done something like this before. So let's just do it, and then we'll apply the check, okay? Now, if I look at C, man, I've got 2 radicals, 2 separate radicals. I can't combine them. There's no skills that I can do to do that. So I actually think it's going to be a little bit easier. Let's get 1 radical on one side and move the other. That way we have 1 on each side. So let's start by doing that and see if that's going to help me in any way, shape, or form. And if I do that, I get radical x plus 1 is equal to 1 plus radical 2x. All right, well, that doesn't look that great, but it does a lot for us. And here's why. So let's square a square root. If I do it to the left, though, I have to do it to the right. But now what that does for me is, squaring the left side leaves me with x plus 1. So I was able to get rid of one radical so far, and that's definitely going to be helpful. Now the right side is going to be a little bit more. I'm going to do that one over here. 1 plus radical 2x. 1 plus radical 2x. If I FOIL this out, 1 times 1 is 1. 1 times radical 2x is radical 2x. Radical 2x times 1 is also radical 2x. And do you guys remember what happens when you multiply any radical by itself? You just get what's on the inside. So this is actually going to give me plus, what is that? Plus 2x over here. So just keep that skill in mind, and this can actually simplify to 1 plus 2x plus 2 radical 2x. So let's just carry that down over here. Now, what just happened? by moving that one radical to the other side and then going straight to squaring them, I was actually able to go from 2 radicals down to 1 radical. And that helps me tremendously because now I want to isolate that new radical, okay, that 1 radical. So what we're going to do is let's subtract 1 and let's subtract 2x on both sides. And let's see what happens there. These 1's cancel out. That's going to give me negative x over here. These cancel. I'm left with 2 radical 2x over here. Can I do anything now? Well, the radical is not isolated yet. So what do I want to do from here? Let's divide both sides by 2. And now what that's going to do for me, I'm going to scroll down a little bit more. I get negative x over 2 is equal to radical 2x. What can I do from here, everyone? Well, now I just have 1 radical. It's on one side by itself. I'm going to square it. But if I square the right side, I have to square the left side. So negative x times negative x is positive x squared. 2 times 2 is 4. 2x times 2x, radical 2x times radical 2x gives me just 2x. So I'm going to cross multiply here. This is going to give me, I'm going to get, guys and girls, I'm coming over here, okay? I'm going to get x squared is equal to 8x. Let's move this 8x over and factor. So I have x squared minus 8x is equal to 0. This factors to x minus 8 is equal to 0, giving me answers of x equals 0 and x equals 8. Now, at the end of the day, what did we do? We still just solved a radical problem. So because of that, I do need to check this. Now, it can be a mental check. You can plug into your calculator, but you must check both answers. So I am going to write it down. You don't have to do it, but we always check in the original. So I've got radical 0 plus 1 minus 2 times, radical 2 times 0 is equal to 1. That gives me radical 1 minus radical 0 is equal to 1. 1 minus 0 is equal to 1. 1 equals 1. This one works out. X equals 0 is a good answer. Okay, so that one does work, but I have to check the other one. I've got radical 8 plus 1 minus, hold on, I don't like how that looks. Radical 8 plus 1 minus radical 2 times 8 is equal to 1. This gives me radical 9 minus radical 16 is equal to 1. Square root of 9 is 3. Square root of 16 is 4. 3 minus 4 is negative 1. Does negative 1 equal 1? It doesn't. So this one rejects, and my only answer is x equals 0. Okay, so just be aware of that. Although that problem looked pretty terrifying from the start, it actually wasn't too bad. We just need to make sure that what we're going to do is we're going to move radicals from, we don't want 2 radicals on one side, we want 1 on one side, and then we can move everything over. You probably have to square things twice in that situation, okay? But that's okay, it was very manageable. We didn't really have any calculations that were too out of control there. So just pay attention to stuff like that, okay? Let's see what we have next here. So some fractional exponents. Similar to everything that we've been doing, you want to make sure that you're going to isolate the term, isolate the term that has that fractional exponent. So in letter A over here, I need to start by dividing both sides by 2. I now have x to the 1/2 is equal to 3. Now these are, we definitely touched upon these in Algebra 2. We do a whole lesson on them. When you have a fractional exponent, you raise both sides to the reciprocal. So what's the reciprocal of 1/2? 2 over 1. But if I do it to the left, I have to do it to the right. What's going to happen here is that these are going to cross out, and I'm just left with x. 3 raised to the 2 over 1 you can do in your calculator, but hopefully everyone knows that's just 3 squared, which is 9. And you do want to check these in your calculator, a quick mental check like we have right here. These are other ones that we want to check for, but just to save some time, this one does work out, guys and girls. You don't need me to go through that. It's something like letter B that gets a little bit more into it, I guess. If you look here, I do have this 1 minus x to the 2/3 is equal to 4. Now, just like before, the term with the fractional exponent is already isolated. So we want to go straight to raising both sides by the reciprocal. Now, the reciprocal of 2/3 is 3/2. If I do it to the left, I have to do it to the right. So with that, what's going to be left? Well, these cancel. I'm left with 1 minus x. 4 raised to the 3/2 power. I do hope, I know in lesson 2 we went over what to do here. I'll do it quickly over here on the side. 4 raised to the 3/2 is the same as the square root of 4 to the 3rd. Now the square root of 4 is 2. 2 to the 3rd is 8. You can plug that into your calculator. I do hope that everyone understands that that's what we're going to get there, but I also need you to understand what we talked about in the lesson right before this. If we're solving something by taking a square root like we did right here, what did we say in yesterday's lesson? We need to put down that plus or minus. So this answer here is going to be plus or minus 8. Okay, and now what we're going to have, if we keep going, let's subtract 1 on both sides. I now have negative x is equal to -1 plus or minus 8. I'm going to divide everything by -1. I'll get that x is equal to 1 plus or minus 8. From here, we split apart. X equals 1 plus 8, which is 9. X equals 1 minus 8, which is -7. And then what do we still have to do? We still need to check this, okay? So you guys can do your check mentally. I will try to write down this check because this one does get a little bit interesting, I guess. But if we go back and we check this one now. So what I have here is 1 minus 9 to the 2/3 is equal to 4. Now 1 minus 9 is -8 to the 2/3 is equal to 4. Now again, we went over this in lesson 2. -8 to the 2/3 you can plug into your calculator, but another way to write that is the cube root of -8 squared. The cube root of -8 is -2. Square that is 4. This one works out. X equals 9 is a good answer. Okay. I'm going to do the other check on the right-hand side. If I plug in -7 there, what I have is 1 minus -7 to the 2/3 is equal to 4. 1 minus -7 is 8. So I have 8 to the 2/3 is equal to 4. Again, this is the same as the cube root of 8 squared is equal to 4. 2 squared is equal to 4. 4 equals 4. This one also works out. Okay, so in this example, both of these problems worked out. Okay, that is something there that if you don't put that plus or minus symbol, you don't get both answers there. So you're only going to get partial credit on something like that. So you must make sure that you are taking, whenever you take a square root of something, you must put that plus or minus symbol, okay? You have to put it there, otherwise you're just going to keep losing points on that. But now everyone's favorite, let's go back to some rational equations, okay? These ones, it's super important that we make sure we factor all of our denominators. So if you look in question A over here, everything is already factored, but I like to space these out just because we're gonna need to do a lot. We're gonna need to multiply by the least common multiple. So it just makes your life easier if you leave some space. Now, if you look at this example, x minus 2, x minus 1, x minus 1, x minus 2, what is your least common multiple? What can you multiply by? For a rational equation, we want to make sure that when I go from this step to the next step, that there are no fractions remaining. Okay, so what we want to do here, and what I want to look for is I want to make sure I'm multiplying something that gets rid of all of my denominators. And what I'm going to choose for this one is if I multiply everything by just x minus 2, would that cancel everything out? So if I only multiply by x minus 2, this denominator goes away. So far, so good. Does anything go away over here? No. So I didn't choose the right thing. So I want to make sure that I'm not just multiplying by x minus 2. What would get rid of x minus 1? X minus 1. So I'm going to multiply by x minus 1, x minus 2. And now let's see if everything goes away. So if I try to cancel everything out now, these x minus 2's go away. This x minus 1 goes away. This cancels with this, and this reduces with this. Do I have any fractions left? Well, let's find out. Okay, I'm going to be left with 3x minus 1 here, but no fraction. Over here, I'm going to be left with 1x minus 2. Again, no fraction though, and that's what we're looking for, is we don't want any fractions left. Plus, well, I just have 7 left over here. So there are no fractions. Now I know that I chose the right thing. From here, it's just a matter of solving whatever is left. This is going to give me 3x minus 3 is equal to x minus 2 plus 7. I'm going to be left with 3x minus 3 is equal to x plus 5. This turns into one of those first degree equations that we did in the other lesson. I like to get my variables on the left, so I'm going to move this x, and I'll move this 3. I'm going to get that 2x, that cancels, is equal to 8. Divide both by 2, and I get x is equal to 4. Now, I need to check these, but it doesn't have to be the type of check that you think. I do want to make sure that none of my denominators are going to go to 0. So if I plug in over here, what is 4 minus 2? It's 2, not 0. That's all you need to make sure. 4 minus 1 is 3. So I'm checking all of these. And when I plug in this 4, nothing happens. So this, nothing goes to 0, I should say. So that is a good answer. Okay, I did the check. You don't have to physically check everything. Just plug your answer into the denominators. Okay, so that's letter A for us. Let's go on to B over here. We can try a couple of different things. This one looks a little bit simpler than the last one. So what I'm going to try to do in this one is I just want to cross multiply this. Cross multiplying is something that you guys have been doing for super long. So in this problem, I've got that 2x over x minus 3 is equal to 4. And I'm going to put this 4 over 1. The reason I can do that is, or the reason I should do that, is just so that it makes my life easier when I come to cross multiplying. I'm going to be left with 4 times x minus 3 is equal to 1 times 2x. If I distribute this, I'm left with 4x minus 12 is equal to 2x. Okay. Let's move this 2x over. If I move that 2x, I want to move this 12. That's going to give me 2x, this cancels, is equal to this cancels. 2x is equal to 12. Divide both sides by 2, and I get x equals 6. If I take that 6 and I plug into the denominators, so I'm plugging in right here. 6 minus 3 is 3. This is a good answer because it did not go to 0. Okay. If you want, nothing's stopping you from checking fully, but you just don't have to. It kind of turns into a little bit of a waste of time, but again, it's okay if you want to. I believe we've got one more problem over here. Now, this is another one where what we're going to want to do here is we're just going to want to solve by, cross multiplying. But this is going to happen more often than not, or a fair amount of times, I should say. I don't want to say more often than not. But if I go to 1 minus 2x over x squared plus 1 equals 0 over 1, well, what I'm going to have over here, when I cross multiply, I'm left with 0 times x squared plus 1 is equal to 1 times 1 minus 2x. Well, ladies and gentlemen, what's anything times 0? It's 0. So this goes away entirely. I'm now left with 1 minus 2x, which is just what your numerator was. So what I'm trying to get you to realize is whenever you're equal to 0, what you're allowed to do is take your numerator and just set that equal to 0. Okay? I subtract 1 on both sides. I've got negative 2x is equal to negative 1. Divide both sides by negative 2. I'm going to get x equals 1/2. Okay? Now, again, we want to check it. We want to make sure 1/2 squared is 1/4. 1/4 plus 1 is 1 1/4. This is a good answer. Okay? So I believe that is our lesson. Let's just double check. Yep, I don't have anything left here. So that's everything we've got for you in this lesson. Again, if you have questions, make sure you're asking. Hopefully, now that we've reviewed all the different types of functions and different types of equations that we're going to see, you now have a better understanding, or better, you remember better what to do on how to solve these equations. So like I said, as always, if you have questions, you've got to make sure you're asking. Either way, I will see you guys soon. Enjoy. Have a good day.